Hello students, welcome to Educate. Today we are going to study the basic concept of LCR circuit, resonance condition, and after that we will study concept of transformer. So let's start. So what is LCR circuit? We have studied about the circuits containing L, C and R separately, and in those cases we have seen. So let's have a quick review. Suppose we have this AC source and there is a resistor. In that case, here voltage will be V equal to V0 sine omega t, where V0 is maximum voltage. This is sometimes written as Vm, so don't get confused. And the current is given by I0 sine omega t. So what do we observe? Here current and voltage are in same phase. So graph will look like this. If this is voltage, then current will be like this. Correct? So this is current. Both are in same phase, and in this case, if we calculate average power consumed, if you remember, so it is Vi, and then if we evaluate it further, so it comes out to be Vrms into IRms. Do you remember it? I told you the concept. We put these values and then this becomes V0 I0 divided by 2 times average value of sine square omega t. Is it correct? No. Here we are putting these values V0 I0, so 2 will not be there, just V0 and I0, and then sine square omega t, and sine square omega t has average value half, so this becomes V0 I0 divided by 2, or we can write it V0 divided by root 2 multiplied by I0 divided by root 2. So this will become Vrms into IRms, right? So this is average power consumed in case of AC circuit containing resistance. Then we have studied another thing, and that thing was AC circuit containing inductor, and we studied about power consumed by it. So when there is AC circuit containing inductor, so figure will be this is AC source, and here there is inductor whose inductance is L. If you remember, inductive reactance XL is given by 2 pi f L, right? And in such a case, we find here equation will be V equal to V0 sine omega t, right? And here if we find the equation of current, so that is I0, and here what happens? Do you remember? It becomes cos omega t, right, with negative sign. So I'm not deriving the result, right? So what will it become further? So we write it as I0. This is sine omega t minus pi by 2. Then we say that in such case, what happens? Current lags voltage by pi by 2, and here I0 can be found by V0 divided by XL, right? And if you remember, graph is like this. If this is voltage, then current will be like this, right? So this is current. So it is clear that current lags voltage by pi by 2. Then comes next one. Next one is a capacitor in AC circuit. So when capacitor is connected to AC circuit, then what happens? So here there is a capacitor and this is AC source. This all you have studied, that is why I am not going in detail. Voltage applied will be V0 sine omega t. In such case, in this case, we find capacitive reactance, that is 1 upon omega c or 1 upon 2 pi f c, right? And here if we find current, so I equal to I0, and it becomes a sine omega t plus pi by 2. So here we say that current leads voltage by pi by 2, and I0 will be equal to V0 divided by XC, right? Where XC is this much. And if we plot a graph, so graph will look like this. This is voltage and current will lead it by pi by 2. So current will start like this. Like this, right? Now we are going to study LCR circuit. So what is that? So LCR circuit means inductance, capacitance and resistance, all three will be connected in series with the AC source. So we can draw the diagram here. Suppose this is L, then there is capacitance C, then there is resistance R, right? And this is AC source. Now what happens? Here inductive reactance is XL, that is 2 pi FL. Capacitive reactance XC will be 1 upon 2 pi FC, and resistance is R. Voltage across this is VL, voltage across C is VC, and voltage across resistance is VR. These two voltages will be in opposite phase. So if voltage across resistance, we write the direction. Here we can write the direction. Suppose this is VR and this is VL, then this will be VC, right? So VL and VC will be in opposite direction, and there will be a case when VL and VC will be equal. In that case, net effect will be 0. So here, if we find total voltage, so total voltage will be equal to voltage across inductor plus voltage across capacitor plus voltage across resistor. So applied voltage will be algebraic sum of all voltage, but actual voltage will be net effect. So we can say, suppose if VL is greater than VC, as I told you that this is direction of VL, this is direction of VC, right? If VL is greater than VC, then what happens? Net voltage will be in this direction, and this is VR, right? And this will be VL minus VC. So net voltage can be found by using Pythagoras theorem. So effective voltage, let's write it as V effective. So that will be equal to square root of VR square plus VL minus VC, VL minus VC whole square, right? Now here if we find resistance, so same situation will be for resistance, and in such case resistance will be called impedance, right? So let's denote it as Z, this angle as phi, and here it will be XL minus XC, and this is R, right? So we can apply Pythagoras theorem. This angle is 90 degree. So impedance Z will be equal to square root of R square plus XL minus XC whole square, right? And suppose we want to find out current, so I will be equal to V. Here we are talking about RMS values, so IRMS will be VRMS divided by Z. Now there will be one condition that is called resonance condition, and in case of resonance condition, what happens? This term becomes zero. That is, either you can say voltage across L is equal and opposite to voltage across C. In that case, XL minus XC becomes zero. So if XL minus XC becomes zero, then what do we get? We will get frequency corresponding to a resonance, right? So let's see what it is. Since Z equal to root of R square plus XL minus XC whole square, and for resonance what happens? XL equal to XC. So this term will vanish and Z equal to R. In that case, current will be equal to voltage divided by Z, that is V upon R, right? And here if we want to find out what is average power consumed, then it will be equivalent to power consumed in AC circuit containing R. So it will be equal to VRMS into IRMS, right? So this value we will get, and here at resonant condition, suppose we want to find out frequency, what is the resonant frequency? So we can easily evaluate. So resonant frequency will be XL minus XC equal to 0, or XL equal to XC, but XL equal to 2 pi FL and X equal to 1 upon 2 pi FC, right? So here we can keep this F in LHS. So F square equal to 1 upon 4 pi square LC, or this gives F equal to 1 upon 2 pi root LC. This is resonant frequency, right? Suppose we want to write it in terms of omega, angular frequency. So we can take this 2 pi term to LHS. So we will get omega equal to 1 upon root LC. This can also be written as omega R 1 upon root LC. So this is condition for resonant, and we have found resonant frequency and corresponding angular frequency. Now we are going to see concept of transformer and its types. So okay, so transformer is based on concept of mutual inductance. We have already studied what is mutual inductance. So here we are going to study transformer, right? So it is based on mutual induction, right? What is mutual induction? Whenever there is change in current in one coil, then there will be flux change in associated coil. If you remember that, suppose this is one coil, take it like this. Suppose this is one coil in which there is a power source, means battery, and here there is a tapping key, and there is another coil. Suppose this is, say, primary coil, this is secondary coil, and it is connected through a galvanometer. And when this tapping key is pressed on, in that case current will flow in it, then there will be flux change in this, and because of that there will be deflection in galvanometer. So on this principle transformer is also based. So let's see the types of transformer and other related facts. So in case of transformer, here there is AC source, this is primary coil, right? And here there are laminated cores, and after that there will be secondary coil. So I'm just drawing this up to here. Later on we can draw different situations. So here this is secondary, this is primary. Now suppose primary has turns N1 and secondary has turn N2. So we can find turn ratio. Turn ratio, say it is K. K is N2 upon N1, right? On the basis of this turn ratio, we can decide the type of transformer. If N2 is greater than N1, what does this mean? Number of turns in secondary is greater than number of turns in primary. Then it will be called, then transformer is called step up, right? This is called step up transformer. And what does it do? It increases the applied voltage, because voltage appearing depends on number of turns. We will see the relation later on. Similarly, if N2 is less than N1, then transformer is called step down, right? So there are two types of transformers. Number one is step up, in which number of turns in secondary are larger than number of turns in primary, and the second one in which number of turns in secondary is less than number of turns in primary. So that is called step down transformer. So here let's write the relation between voltage and number of turns. So relation between voltage and turns. So relation between voltage and turns is, here E is voltage proportional to N. So we write N2 upon N1 is equal to E2 upon E1, right? Voltage is in the secondary upon voltage in primary. Number of turns in secondary divided by number of turns in primary. And if we say power, so power is, VI. So here we write efficiency. Efficiency say eta. If efficiency is 100%, then we write output power divided by input power, which will be 1. Output power means output voltage and output current. So E2 into I2 divided by E1 into I1, right? So if efficiency is 1, means 100%, in that case, what do we get? E2 I2 equal to E1 I1, or E2 upon E1 will be equal to I1 upon I2, right? This is one relation. What we have seen here, E2 upon E1 equal to N2 upon N1. So we can say E2 upon E1 equal to N2 upon N1 is equal to I1 upon I2. So this is basic relation, and you will be given certain questions and you can easily solve. There are certain losses, like there will be flux loss, humming loss, and copper loss, etc. So you can read them one by one. You will understand the concept. So this is all about transformer. And other related facts you can read in textbook. We will do numericals based on these concepts in next lecture. Thank you for watching. Team Educate.